With Hurricane Andrew bearing down, most people are hurrying to leave South Florida as fast as they can. But Emmett Williams, hurricane hunter and amateur photographer, is rushing to get as close as possible to record what will become one of the most devastating storms ever to hit the continental United States.
Nothing was safe in Homestead that night.
He and a companion weathered the storm in a hotel chosen for its concrete construction.
All we could see was the flashes from the fuses blowing on the transformer poles.
Wow, this is serious.
The storm rages for 5 hours, with winds gusting over 175 miles per hour.
Even though I had been through many hurricanes in the past, I was becoming quite concerned.
They are forced, finally, into the bathroom.
It's the only room we have left in our room. The rest of our room is now gone.
Even here, the storm's fury is evident.
The pressure's so great that the toilet has been sucked absolutely dry. Wow, drop a piece of toilet paper in there again. Watch what happens to this toilet paper going in the toilet. It gets sucked down. Wow.
2 hours later, they venture outside and begin to witness the damage wrought by Hurricane Andrew. There are billions of dollars worth of property damage, but relatively little loss of life. This was not always the case with the hurricanes of the past.
20 years later, I still ask the same question: why? Why didn't we die? Why did we live? And the only thing I can say is that the good Lord up above wanted us to live so that we could tell people, you know, if anything can be said about a storm or about a hurricane is, you know, when a hurricane comes and when a storm comes, get the hell out.
August 1969, Hurricane Camille. Few survivors will ever forget the deadly terror this storm unleashed on the Mississippi coast.
We were inside the house. We had to swim to the windows across the front of the house, which had already blown out from the pressure and the wind and everything. And we climbed up alongside the chimney onto the roof and floated in the backyard. Well, that's where we stayed for the rest of the night, getting pelted by parts of other houses, tree limbs, and just getting beaten by the rain that was so heavy.
The Mississippi coast lay in ruins, wrecked by a 25-foot dome of seawater, the storm surge. But Camille wasn't the worst. Galveston, Texas, the year 1900. A hurricane flattened the city, killing 6,000. It was the most devastating natural disaster in United States history. Across the world in 1970, a massive storm swept into the Bay of Bengal, drowning 500,000 people. It was one of the worst natural disasters anywhere. But seen from space, these storms, called hurricanes in the Atlantic and typhoons or tropical cyclones in Asia, appear deceptively serene. Made up of clouds and rain circling a clear center, the eye, the hurricane is a gigantic spiral up to 1,000 miles wide. Summer is hurricane season, peaking in September. It's Labor Day weekend, 1988. Thousands crowd beaches and resorts along the Gulf of Mexico. But a potentially deadly threat is moving toward them. Still far out at sea is a storm that will become known as Hurricane Gilbert. Where will Gilbert go? How bad will it be?
Any kind of malfunction prior to rotate, I'll reject and I'll abort it. Anything after rotate, I'll fly the plane straight ahead.
South 43, clear for takeoff.
Even now, an airplane is about to leave Miami for a reconnaissance flight directly into the eye of the storm. Flown by the National Oceanic and Atmospheric Administration, NOAA, this specially equipped aircraft is designed to help scientists understand hurricanes and better predict their often erratic path. For the next 10 hours, researchers will monitor an array of advanced radar and sophisticated sensors. They'll crisscross the storm, reading its vital signs and relaying them back to forecasters on the ground.
But the surface winds look like they're about 70 knots now. And flight level, we're only 60, so we're above the most of the storm, looks like.
Let me see what the smart fans decide.
Okay.
Forecasting depends on understanding, and lead scientist Hugh Willoughby uses these same measurements in his effort to figure out the dynamics of the storm and its environment.
The sea surface is looking pretty boiling. Can't see anything right now.
The biggest mystery is how does the hurricane interact with its surroundings? With the surroundings in the atmosphere. That controls the motion. In a big way, it controls the intensity. I think that that's a solvable problem.
So far, hurricanes have proven notoriously unpredictable.
That the beginning of the hurricane conditions will start there anytime after dark this evening.
And no one knows that better than forecasters at the National Hurricane Center in Miami. Information about Hurricane Gilbert is now pouring in from advanced weather satellites, remote weather stations, and reconnaissance aircraft.
All right, see if we can get a hold of Mexico and see if, because we're talking about 36 hours.
It's up to scientists like the center's director, Bob Sheets, using their knowledge of hurricanes and a variety of computer models to forecast what the storm will do and who will be affected.
Let's say, when you talk to them, say that it could be there within 12 to 36 hours. See whether they want to put up. They said that at least at 6 o'clock they don't want to scare these people because it's going to be too far.
Yeah, right, great. Got 30 seconds.
Sheets finds himself in a role most scientists never experience. Surrounded by a swarm of electronic media, he'll have to communicate his findings almost immediately to an anxious public.
During the tropical depression phase, the tropical storm phase, you get heavy rains, gusty winds.
It could intensify further.
That's right. It's a large system. It's developed its own environment, and so it just generates and feeds on itself.
As the hurricane nears land, the stakes begin to rise.
When you're dealing with the hurricane problem, there are more things involved than forecasting per se. If we put up a forecast, and say we put out a forecast and indicate the forecast of hurricane on the coast in 48 hours, we are creating a mechanism that starts turning, a wheel that starts turning, that's a multi-million-dollar problem. We can't just forecast exactly what we feel is going to happen.
24 hours before predicted landfall, the Hurricane Center issues a warning.
We're going to violate a rule one way or the other in terms of strictly interpreting the manual. I think it'd be better to not put up the watch and just forecast the parameters.
Local officials will usually call for an evacuation, advising residents to board up their homes and businesses to close down. The cost? $50 million for every 300 miles of coastline.
Well, we've seen Hurricane Camille in 1969. We've seen Hurricane Allen in 1980 that were similar to this one.
Despite the economic trade-offs and the inevitable false alarms, the National Hurricane Center's effort to coordinate hurricane prediction and preparedness has paid off. The number of hurricane deaths is steadily declining. The first hurricane warning system was set up in 1898, a fleet of ships stationed off the American coast. But for decades, meteorologists had no way to track storms far out at sea. During World War II, American ships in the Pacific were caught unaware and battered by typhoons. 1944 saw the beginning of a whole new era in hurricane tracking. Using a powerful new tool, radar, military crews began flying into hurricanes to determine their strength and direction. While better tracking could save lives, it could not protect vulnerable coastlines from spiraling property damage. In the early 1960s, scientists believed they had an answer.
If only the force of the hurricane's winds could be reduced, the toll in death and damage could be greatly lessened. Is there a way?
The way was Project Storm Fury, an active assault on the hurricane. A fleet of planes would drop silver iodide into hurricane clouds. Ice crystals would form, disrupting the storm's delicate heat balance and sapping its strength. But after 20 years, Storm Fury never produced conclusive results. The project was doomed by heavy restrictions on seeding hurricanes too close to land and by doubts about its scientific assumptions. Today, scientists have turned again to tracking hurricanes and improving the accuracy of their forecasts. Advanced satellites allow them to monitor the entire life cycle of a hurricane. But they still lack what they need most: detailed information about the vast tropical environment in which the hurricane forms.
Many people believe that when we launched satellites, we solved the problem of understanding the state of the atmosphere. But unfortunately, a satellite is, for the most part, just a pretty picture. Sometimes they're very pretty pictures. They tell us there's a hurricane there. What they don't tell us, or they don't tell us very well, are what we really need to know about the environment of the hurricane. For example, the flow of air. It's very, very difficult, if not impossible, to deduce from a satellite picture, or a sequence of satellite pictures even, what the flow of air is. And without knowing that, we can't possibly say where the hurricane is going to go. That is the main limitation in forecasting hurricane tracks.
Most Atlantic hurricanes are pushed west in the flow of air spiraling around a high-pressure zone just north of the tropics, the Bermuda High. But once they head north, hurricanes often fall under the influence of weather systems over the continental United States, becoming highly unpredictable. August 1985. Space Shuttle astronauts watched as lightning flashed along the edge of Hurricane Elena. On the ground, Elena was giving forecasters fits with one of the most bizarre tracks in memory. The storm headed straight for Mississippi, and the coast was evacuated. Then Elena slowed down, turned east, and hovered for days just off Florida. After the crowds returned to the Mississippi coast, Elena suddenly looped back, and the beaches were evacuated again just before it hit land. A weather system called a trough, shown in red, had blocked Elena's path and sent it east. Then a high-pressure zone pushed it back to Mississippi when the trough moved by. A few weeks later, Hurricane Gloria formed in the Atlantic and turned north. Its final target could have been anywhere between Florida and Maine. It grazed the coastline, eventually hitting New England.
Okay, the hurricane is not like a block of wood floating in the water that the fluid that the environment is. It's more like a water balloon floating in, or like a wad of jello floating in the river of wind, if you want to look at it that way. If you push it in one direction, it's not necessarily going to go like if you push a piece of wood. If you push it in a certain direction, it may spread out or decide to wiggle off to some other direction. So it's the interaction of the environment again. It's two fluids. It's not a solid entity embedded in a fluid. It's two fluids interacting together. And it's this interaction is very subtle. And the whole concept of this interaction requires some of our most sophisticated computer models just to understand.